Hi, welcome to Alibaba Activate online conference. I'm Justin Song. I'm lead architect of Alibaba Cloud Innovation and Architecture team. Today I'm going to present X-Dragon. For people who do not know X-Dragon, here is very clear and brief definition. X-Dragon is our Alibaba version of hypervisor stack, as well as related software and hardware offloading and disaggregation technologies. The X-Dragon is Alibaba Elastic Compute Service Foundation. Today I'm going to show you first to walk you through the history of virtualization, followed by Alibaba X-Dragon architecture evolution, and finally I'm going to give you our practice and benefit analysis. So far we have talked about virtualization. So you may wonder why virtualization is so important to cloud computing. The number one issue for cloud computing is it has to be elastic. To customers, when you deploy your applications on our public or private cloud, you want to pay as you go. When your application utilization is high, you want to have more servers. When your utilization is very low, you need to release that compute resources. Also to our cloud providers, to make the business sustainable, we need to provision limited resource. And also we need to make sure we can migrate the user instances. All of that means we need a method to make compute more elastic. Today, the most widely used technology is virtualization technology. So-called virtualization, that means we compose the computer resource on our cloud, and also we provision that instance as an instance to customers. The technology called virtualization technology. Now let's stepping back a little bit. I will walk you through the history of virtualization. In 1973, in a very famous paper, virtualization technology was discussed. For first time, it defined what hypervisor is, what its functionality should be, and what's the guideline to design an efficient hypervisor. And after that, over 20 years, the virtualization evolves progressively but slowly until 1998, when VMware founded. VMware invented so-called binary translation technology. Also, they make a commercial solution to make virtualization usable to a lot of customers, especially enterprise customers. And after that, especially in mid-2000, until 2014-15 timeframe, that's the golden 10 years of the virtualization technology development. Hardware vendors like Intel and AMD, they start supporting trapping, which means for most of the time, instructions, they just execute natively. There's no need to emulate that instruction. So performance can be as good as a bare metal. Only when there is privileged instruction, then there is a hardware supported trap. And Intel, AMD, hardware vendors, they created VTD and VTX virtualization technology. And on the software side, the Zen project, they found a very clever solution. They instrumented Linux open source software, and they replaced some privileged instructions with hypercall. And in that way, they can do native software execution on hardware. Also, only when needed, the virtualization monitor, VMM, will be involved. And the privileged instruction will be executed in the backend. And a few years later, KVM project, they had a lot of optimization. They never need to run in the everything in the kernel mode. Also, they significantly lowered the user space overhead. So KVM became very popular. Until today, a lot of cloud providers, they still employ KVM to implement the software-based virtualization platform. We call the software either Zen or KVM-based virtualization technology, legacy or traditional virtualization technology. I will show that later in next slide. And after 2014-15, when KVM matures, we found as the need of the cloud computing cloud customers, they have very fast performance requirement growing. And so very quickly we found software-based solution cannot meet their need. The cost will escalate very fast. Then Alibaba and many other cloud providers, they start providing the hardware or firmware assisted virtualization offloading and disaggregation technologies. And in Alibaba, we call it X-Dragon. I will talk about that X-Dragon later. Here in this slide is the traditional or legacy virtualization architecture in cloud data center. On every physical center, customers will run their applications in a virtual machine, VM. And inside the VM, there is abstracted compute, network, and storage resource. For compute, it can be named as vCPUs, virtual CPUs. And for network, it can look like a real network adapter, but it's emulated. And similarly, like storage, it may look like a real storage volume, but again, it is emulated and supported by the hypervisor. Also, on the same physical server, there is a hypervisor running to support the VMs. Actually, inside the hypervisor, there are VM monitor, and a lot of device models, and also scheduler and a memory manager. And we call the scheduler and memory manager, and sometimes the AIOps applications. We call those kind of applications needed to run the physical server and also to support the virtual machine. We call it host applications. The host applications are very necessary to do the maintenance to make sure the server is running is in a healthy state. Also, the hypervisor will be responsible for trapping. And also, there is a backend or bottom half of the hypervisor. It may interact with the physical resource, compute, network, and storage. The backend compute resource can be very simple instruction supported on the local server, or it can be a full function server on different network segments, or it can be a fleet of servers on the cloud. Okay, that's the traditional or legacy virtualization architecture. In this slide, I show the challenge or problem of that legacy architecture. The very first problem is the host applications and virtual machines of customers. They coexist on the same physical server. Because of the coexistence, they may compete for the same resource. This may result in some performance jitter. And also, there may be some safety concern raised by customers. They may wonder, your host side applications are running together with me. Maybe you can see my data, right? And we also know there can be side channel attack. So due to that concern, people extremely very sensitive applications, they are really concerned about that coexistence. And the second issue is about overhead. The host applications and the hypervisor, they consume the physical server's compute resources, maybe 5% or 10%, depending on which cloud provider's optimization level. But still several digit, even 2-digit percent performance overhead. That means we cannot provision 100% of the physical server compute resource to customers. And the third problem is the emulation or I/O implementation method. The software-based network and storage engine, typically they incur a lot of performance overhead. Because on cloud, the network and storage, typically they are disaggregated or separated from the compute nodes. So when VM application needs even a single line of storage access or network access, that may mean very complex backend servicing. So the overhead can be very high if it's implemented in software. And we saw in some KVM-based prototype, the software-based network and storage implementation may slow down the virtual machine by more than 10%. And number 4 challenge is about bare metal instance provisioning. Because the hypervisor and the host applications, they run on top of the physical server. That means anyhow, no matter how you do optimization, even if you optimize the hypervisor and the host application to use only 1% of your server, still is 1%, it's not bare metal. And users who have strong requests for bare metal, they cannot get bare metal instances. And the bare metal instance can be very important to the nested virtualization. For example, VMware users, they already have very good implementation based on VMware. They do not want to waste their money. They want to very simple migration solution. Just move their VMware-based solution onto a bare metal platform. Due to that, we do need to provide a bare metal instance to such kind of customers. Okay, here is a summary of the 4 challenges. When we invented X-Dragon, let's restate the customer expectations. They want a higher performance, faster network, stronger storage capability. They want a higher, the better quality of service. They want to run in a safer environment. And of course, they want a lower cost. And due to that, we invented X-Dragon. X-Dragon is a cloud-native virtualization technology. We use a lot of software and hardware co-design methodology to invent X-Dragon. Okay, from this section, I will provide some high-level information about X-Dragon architecture involvement. The evolution since 2015 until this year, almost 1 year. For every year, we have 1 generation of X-Dragon. Let's start X-Dragon generation 1. In the very first X-Dragon, we thought which one we should do. We should offload. And we thought we'd better start, maybe we can start with a network of storage. Eventually, we chose to start with virtualization. And as a result, the first version of the X-Dragon, we can provision bare metal instance to customers. In this chart, you can see we implemented a card, a so-called X-Dragon card, which is a PCIe-based card. The card inside the card, we had X-Dragon SoC and also I/O acceleration engine, and we implemented the full stack hypervisor, and the user applications can run in the bare metal, and they use VirtIO block, VirtIO NAT interface to interact with our X-Dragon SoC. Then their application can run without any modification on the bare metal. They can get the full 100% of the bare metal compute resource. And because the cloud compute resource, everything is based on the VPC or distributed storage. And our X-Dragon card can be a proxy. It's a backend hypervisor. It can get the request on VirtIO block and VirtIO NAT channels from customer bare metal instances. And X-Dragon card will do the translation, do the queuing, and also we find the right resource where the storage is, where the overlay network resource is, where to talk to the other VMs or whatever other network-based cloud resource. In this way, we can implement, we can support bare metal. We can allow them to use a virtualized network resource. Also, for the first version of X-Dragon, we started supporting some security features like ROT support, encryption support. Also, we started supporting Intel SGX. And for flexibility, like hot plugin and hot removal, we support a network, online insertion and removal. Also, we support online dynamic mount and unmount of the storage. Okay, so our X-Dragon first generation, in sum, is a one card, but for every cloud function. That's a major difference from other cloud provider solutions. Some providers may have multiple card, multiple offloading solutions, and we have only one card. This one card, we can do network offloading, storage offloading, and also hypervisor offloading. And we have a lot of other add-on features like intelligent AI ops and security features. It's only one card. By using only one card, we can lower the additional cost to customers. Also, it's easy to have volume requirement on manufacturing capability or advantage with our ODMs. And after 1 year of the first generation of X-Dragon, we had X-Dragon generation 2. The reason we have the second generation of X-Dragon is because we realized we need to offload not only hypervisor, but also network and storage. And the second reason is we needed to make sure we can deliver bare metal virtual machine and also container at the same time. In other words, our platform has to be able to produce virtual machine, bare metal, and also container at the same time. In this way, we can minimize the resource fragments to maximize the value to our customers. As I said, now in this generation 2, we can support network and storage offloading For network, which is VPC, now is offloaded to the X-Dragon card. X-Dragon card can take the network request from the host side, and it will use inside queuing and processing forwarding logic to look up very quickly to do a lookup and figure out the destination and do very quick network communication. And for the storage, it will run the smart, high efficient storage application on the cloud, on the compute node inside our X-Dragon card. There's no need to consume any host side CPU cycles to run the storage applications. For the bare metal virtual machine and container production at the same time, that's implemented also by our X-Dragon card because we implemented standard VirtIO block and VirtIO NAT interface and in hardware. So so long as the customer applications can follow the VirtIO spec, their applications can always run, no matter it's inside virtual machine or is on a bare metal or in a container. And as a plus, in X-Dragon Generation 2, we can do live migration and also live upgrade. Users almost do not feel we are doing upgradation for them. For example, if there's a need to apply a patch for firmware, for software, we can do that silently without asking our customers to stop their service or to migrate their service. And they feel their service not interrupted, and they can continue to provide service to their customers. And we can deliver very high level of SLA service to customers. And another highlight I need to figure out, to point out here is the lightweight Dragonfly hypervisor that we optimized significantly on Generation 2. I mentioned the KVM, and based on the open source KVM, typically user can still experience a couple of points of performance reduction. And even if you do a lot of optimization based on today hardware, like Intel, AMD technology, still the overhead is there. When you have I/O, a lot of I/O transactions, the performance impact is bigger. And in our Generation 2 X-Dragon, we have dedicated a lot of optimization, and we have a new Alibaba version of hypervisor called Dragonfly. In that Dragonfly, we have almost zero overhead and almost no jitter to the performance. And it's compatible, backward compatible with other hypervisors. Users can migrate the Dragonfly-based VM to KVM-based VM. And this year, in September, on Alibaba Cloud Conference, we announced X-Dragon Generation 3. In Generation 3, we have way better performance. We almost double performance of Generation 2. And in last slide, we actually had 512 storage and network queues supported by X-Dragon. And in X-Dragon Generation 3, we can support 1K storage and 1K network queues. Because of so many queues supported at the same time, we can minimize jitter, and we can increase the performance consistency. Even if at a very high level utilization, still customers can feel very constant latency, and the jitter will be very small. And we have hardware supported so-called fast path. for both network and storage. For using the FastPass, hardware-based FastPass technology, we can support a very high number of the concurrent connections. That number can support even like supercomputing or very dense deployment or transactional processing applications of our customers. And even if they have very small instance of VM, but very dense deployment on the generation 3, they can still have enough number of network adapters and storage volumes to run their applications inside their instances. This significantly improves the customer's deployment experience, and there is almost no difference from the bare metal, from the ease of use perspective. The quality of service right now is managed using hardware, and as I said, we have so many queues. Also, we have many tiers of quality of service guarantee, from the software side all the way to the firmware, to hardware, and to outbound network. For every tier, we have the breakdown of the quality of service guarantee. And the X-Dragon card is able to guarantee for each segment, each leg, the latency, the bandwidth can meet the requirement. So the total quality of service on the compute server now is better than previous generation. In this slide, I talk about the availability issue. Availability is very critical to cloud customers. Typically, we use both software and hardware method to improve availability. Availability, if we have unexpected failure rate, if the rate is too high, the customers may have to interrupt their service, and they may, if it's a critical node that has a fatal failure, it may cause the whole application to go down. So the software and hardware resilience on the cloud is very critical. And the distributed software, like redundancy, like multi-copy, that's the software side solution. And our X-Dragon architecture, that's the hardware resilience solution. Because we offloaded hypervisor, and also we separate network, storage, all of that components. Because they are disaggregated, there is no single point failure from the hardware perspective. Then our X-Dragon helps significantly improve availability of customer service. I will have some data analysis later. And in the future, we expect the virtualization technology will continue to improve. There are a lot of opportunities to make the virtualization solution better. And as the new forms of the cloud applications show up, and we may have to change and improve our hardware design. So X-Dragon evolution is always in progress. Okay, I will talk about the practice and do benefit analysis. So far, we have been using X-Dragon architecture widely on Alibaba economy. And for Alibaba economy, majority of the application is e-commerce. And a lot of e-commerce applications have been deployed based on X-Dragon architecture. I will show you some results. to show the advantage of the X-Dragon. And also for our public cloud and private cloud customers, a lot of people, they say they start using X-Dragon architecture and they lack X-Dragon stability, also their performance. Sometimes the performance is even better than bare metal. And we expect to see X-Dragon will be more and more deployed on Alibaba Cloud, and it will be a major dominant architecture on Alibaba Cloud. Okay, on this slide, I will give you an example of Alibaba economy use case, which is X-Dragon plus container. The container you can see on the left-hand side. The containers they run inside a big virtual machine, and in the big virtual machine there may be many containers, and application developers, they decide how to deploy their containers and when to go up, when to go down. And they have network abstraction on the VPC. Also the interface based on the X-Dragon, we provide the virtualized network service to the virtual machines and also to the containers. Because we offloaded the hypervisor, the hypervisor right now is running in the X-Dragon engine. So there is no negative impact, no competition with the container-based applications. So the container application developers, they can focus on performance optimization, and they do not have to worry about any offloading, any hypervisor overhead. Because of that, we found the QPS, the query per second metric, goes up by 30%, and the response time metric, it goes down more than 90%. The response time, that's a very important metric as an important indicator of the responsiveness. When the customer doing shopping online, they expect for after click, they need as soon as possible response. And the RT improvement is very important to them. And because we implemented VPC and EBS using hardware, we can do acceleration. Now the customers can see, they can have the physical bare metal level network and storage performance. And as a result, their CPU, their container or virtual machine CPU utilization continue to go up because the CPU doesn't have to wait for any network or storage to come back, especially for asynchronous transactions. There is less wait time, and the CPU can continue to process more transactions, and as a result, the utilization goes up. And in this chart, I show you some numbers to explain why we have the latency reduction. The x-axis is utilization of the workload, and the y-axis is the latency in milliseconds. The lower, the better. You can see the bare metal, which is a blue line, and the X-Dragon, which is the orange line. When the utilization is not high, say lower than 40%, the two lines almost overlap, almost no difference. Starting at 50% utilization, you can notice the bare metal latency goes up exponentially. And our X-Dragon latency can stay within the 20 millisecond requirement. It's very important to stay below 20 milliseconds to guarantee a good user experience. For bare metal, because the latency goes up so quickly and so sharply, then very likely they cannot let utilization to go to 50% or higher. Very likely they have to deploy maybe 2x computer resource to make sure every server utilization is under 40%. But for X-Dragon, you can deploy your applications in a denser way, and your utilization can be higher, can be 70, 80%. Still, you can get a very good response time. That means value to our customers, and you do not have to buy more computer resource. You can get a good enough latency response time. And due to this decoupling of the hypervisor network and the storage, we achieve this. And we will continue to do optimization to make sure the latency or throughput benefit, not only benefit to the e-commerce or the JVM-based scenarios, but also to more other scenarios in the future X-Dragon architectures. So far as we know, in this scenario, we can defeat bare metal in the latency. That's really value to our customers, and you can expect more value at more scenarios. And in this slide, I show you the availability improvement. On the left-hand side, I have two bars, one called mainframe, and the other is the KVM at x86. People should be very familiar with mainframe. That means upper end, high level, maybe very expensive server. And there are a lot of Rust features. Maybe in hardware, they implemented some Rust features. And due to that, the availability typically is high. And the commercial off-the-shelf Intel x86 servers, maybe they do not have higher enough availability because of the price, because of the cost. If we run KVM on top of that commercial hardware, today we see 10x higher unexpected failure rate than mainframe. And our customers, they expect the failure rate to be similar level as the mainframe, but they hope the price can be the similar level as the commercial servers. And our X-Dragon, because it does the offloading of the hypervisor, and it can disaggregate the network and the storage computer resource. And the disaggregated resource can do their Rust feature independently. So as a whole, our X-Dragon unexpected failure rate is at the similar level of the mainframe. That's really a value to our customers. That means failure rate reduced significantly, and they pay almost the same commercial server cost. Okay, that's pretty much my presentation today. If you have any questions, you're welcome to send your questions. Thank you.